And just like in that presentation you saw on the video screen, we've actually brought our satellite to Thailand with us. It fit in Alex's suitcase.
It did. I had a few problems at customs. Bringing a satellite across the border in your suitcase isn't normally done. But this is it, and we'll pass it around so everyone can have a close-up look in a little while.
Yeah, and just like you saw a minute ago, this is not a smaller version of the satellite. This is the actual size that we launch into space. And I will be showing some of the information, some of the imagery that we collect with these satellites over Thailand today. And it is usable information that you can use for a variety of applications. So now that we have a mature satellite design, we're continuing to practice agile aerospace. What that means is we basically embrace what's going on in technology that oftentimes you see in Silicon Valley with companies like with Google or Apple or Facebook, where they're always releasing new products, improving existing products. We do that, and then we actually do that en masse, meaning we actually build a lot of satellites at one time. So instead of one satellite, we'll build 28 satellites and launch them together and put them into orbit all around the same time so that we can increase the size of our constellation very, very rapidly. These are just some pictures of a recent deployment of our satellites from the International Space Station. Typically, they're launched out 2 at a time. You can see the pod there open. That pod actually contains 2 satellites. Over the course of a few hours, we can deploy 2 satellites, 4 satellites, and then that group of 28 gets launched out over the course of about a week. Some more pictures of it. So why are we doing that? It's really interesting, and I think it's quite cool, but there's actually a reason why we're doing that. If you were to approach a commercial satellite company today, an Earth observation satellite company today, and say, can you give me an image of a particular location in Thailand, there's a very high chance that they would say no. Reason is that they don't have 28 satellites or even 10 satellites. They maybe have 1, 2, 3, or 4 satellites, but those satellites are oftentimes doing something that's called tasking, meaning that the government of the US, the government of Canada, another government, a big customer in another part of the world, has already asked them to point their satellite at their own location of interest, and when they do that, the location that you're interested in cannot be imaged. So what that leads to is you have a limited number of observations. For example, if I wanted to be able to monitor the fires and where the smoke is coming from in the northern part of your country, with satellites today, that's not possible to do. With what we're doing, it's actually quite possible to do. So what we're doing is launching numbers of satellites together to the point where we can monitor the entire planet. So you don't have to ask us to take a picture of northern Thailand to see the fires. We will already be collecting that data. Of course, as I mentioned, there's numbers of reasons to do this. Why would we do that? Well, of course, environmental monitoring comes into place. Any sort of natural disaster, fires, floods, having the ability to have imagery right before the event happened, during the event, and after the event will help us manage those disasters much more effectively. Other types of things like agriculture. If you could look at all of the rice fields in Thailand on a daily basis, or even a weekly basis, or even a monthly basis, you would have a better understanding of how big the rice harvest will be this year, if there will be any shortages, those sorts of things. So there are a lot of applications for this type of data. And again, I would like to ask you, what would you do? If you did not have to ask someone to point their billion-dollar satellite at your area of interest, pay a lot of money to get a single picture of your area of interest, if that area of interest was getting imaged all the time, every day, very regularly, and you had access to that information, think about what you would do. So I want to give you some real-world examples. So these are from some of the very early satellites that we launched last year. This is a sugarcane farm in Brazil. This is the image on the 8th of August of last year. It looks like everything's going fine. And typically, we would not be able to get information the following day. But with one of our satellites, we're actually able to get information the following day, and we can see that one of those fields, after it was harvested, was put on fire, and of course, Just like here in Brazil, after they harvest the sugarcane, oftentimes they have problems with smoke and haze in the cities that come from these areas. So it's a very useful tool to monitor where these fires are, where they're coming from, so that we can manage and respond to them more effectively. What if we're interested in monitoring infrastructure? This is in Cambodia, not too far away from here. This was an image that was captured back in December on the 22nd. We can see that there's a dam being constructed. What if we wanted to monitor the progress on that dam to understand how much earth was being moved, how much concrete was being poured? Typically not possible to do from here to remote areas. Just a few days later, we actually captured the same site, and you can see over the span of about 3 weeks just how much progress was made. I'll show that again. You can see part of the dam is completed, one of the side channels was put into place, and lots of ground around the dam has been cleared. And oh, by the way, if you look in the upper right-hand corner, there's smoke from a fire, speaking of smoke. Let me show you an example from your country, and I apologize, I will probably not pronounce this correctly. This is from Wang Nam Kiao. This was just a few weeks ago, on the 3rd of February. You can see in the forested area where there's lots of hills, particularly on the left-hand side of the image there, you can see that there appears to be some agricultural activity on the steep hillsides, which of course can cause problems in terms of runoff and things like that. What if I wanted to look at that same area with other available data? Well, if I go to Google Earth or Google Maps, which a lot of us use on a daily basis to figure out how to get to a restaurant or to a coffee shop, the image that I see is cloudy. I can't even see the place I need to look at. And oh, by the way, this image is actually over 7 years old. It's taken in 2008. That doesn't even give me current conditions on the ground. What are my other options? If I go to one of the other major satellite image providers, the image that they have of the area is older than 7 years, and it's actually also in black and white. Very difficult to monitor agriculture activity if I just have a panchromatic or a black and white image. And if we see the same area there, the activity is completely different simply because my picture of that region is older than 7 years. But with our data, the ability to monitor things in a very current time frame will enable us to manage environmental regulations, agricultural activities in a much more timely manner. I'm going to turn it over to Alex now, and he's going to talk a little bit about our roadmap. Let me just get his presentation up.
Thanks, Bo. Do we have any questions from the audience? Feel free to interrupt, put your hands up, or there's mics. We can also translate, because Bo and I are not great at speaking in Thai, we apologize, but we encourage you to interrupt or ask questions if you have any. So yeah, this will be a pretty short presentation just about where we are today, and we want to demonstrate that we have significant capability today, which we hope many of you will find useful. But we also want to talk a little bit about how we'll be improving our technology and expanding our constellation over the course of 2015. So this is a really short animation, which just shows what we're able to do kind of right now. You will see a number of kind of dots appear on this map. What that shows is actually pictures we have taken in the last 4 months. So in a very short period of time, you'll see that we've managed to cover a significant part of Asia, and specifically kind of Thailand and Southeast Asia here. We understand it's often cloudy in this region, and it's been difficult for other imagery providers to get pictures on this sort of scale. So this animation just demonstrates that we're able to do that right now, and even if there are clouds, because we have so many of the Dove satellites up in space, we just have many opportunities to get a cloud-free picture. I also want to point out that this is not our full constellation size. So this level of capability was actually produced with only about 24 satellites. Our final constellation size is going to be about 100, and we have a number of launches booked this year and next year that will get us to that scale and beyond. So this is just kind of a taster of where we will be. So when we talk about our kind of capabilities, we talk about global land areas.